Hi, this is Thirumal Priyan. I am here to demonstrate the execution of SQL queries with Python and displaying the results of those queries in a website in real time. This is the scenario assigned to me, which is nothing but a university's academic management system. The system is intended to manage information about students, courses, instructors, departments, and the classes. Now, as you can see, these are the schema descriptions of the tables in the database which I use in my demonstration. The tables are the student, course, instructor, department, class, project, and enrollment. Now let me explain about the structure of my project. Here you can see there are three folders. The first one is the application. Here we have the application for the server end. The function of this server is to fetch the records from the database and convert it into a JSON format and post it in the localhost URL. In the website folder, we have the code for the front end. This folder fetches the JSON format file from this URL and display the tables in the website. And in the queries folder, we have the file for each of the queries that I'll be demonstrating in this demo. Now let us initialize the tables in the database. As you can see in this file, I have the code for creating the table and inserting some RAM sample records in those tables, like create table department, course, instructor, student, class, project, enrollment. And these are the queries for inserting the records in those tables. Let me run this. Yeah, as you can see here, the sample data have been inserted in those tables successfully. Let us see those tables in the website which we have created. First, let me run the server. Okay, yeah. Right now the server is running in this code. Yeah, this is the JSON format which is sent by the server to the front end side. Now let us open the website. Yeah, this is the course table, student table, instructor, department, class, project, and enrollment. Now let's start executing the queries that are assigned to. So let's start executing the queries. The first query is write an SQL query to create the table for the student entity, including the composite attribute for the full name and the derived attribute for each. And my second query is write an SQL query to create the table for the project entity, considering it is a weak entity. Now, these two queries are covered in the initialization step we just did before. So let us move on to the next query. Write an SQL query to insert a new student record, including their full name, date of birth, and other attributes. Yeah, this is the code for executing the query. And here we just mentioned the SQL query. Let me run this code. Let me insert a new student record. Bye. Albert Johnson, 2004. Albert dot Johnson and example. Let me run this query. Yeah, the new student record has been inserted successfully. Let us see the inserted record in the website. I have started running the server. Yeah, here is the inserted student record with the name Albert dot Johnson. With this, we completed the third query. Let us move on to the next query. Write an SQL query to assign a project to a student under a specific instructor. Here we have the code for executing the query. Let me assign a new record in the project table. The ID will be 5102. Student ID, let us say it's 4. Let it be a cryptography project. Okay, I have given the query. Let me run the code. Yeah, the new project has been assigned successfully. Let us see the output in the website. Yeah, before that, let me run the server. Yeah, here is the project we just added. With this, we complete the fourth query. Let us move on to the next query. Write an SQL query to find the average number of student courses taken by students. Here we have the code for that. And here's the query which we'll be executing now. First, in the inner query, we are selecting the student ID and the count of the testing course ID. And here we are grouping by the student ID. Now let me run this code. Yeah, here we got the output as 1.667, which is close to 2. If we use a floor function, we will get an output as 1. With this, we complete our fifth query. And the sixth one is write an SQL query to count the number of projects supervised by each instructor. And here's the code for that. Let me explain the logic behind the code. First, we are grouping the records by instructor ID. Then from the project table, we are counting the distinct project ID. This will give the count of distinct projects supervised by each instructor. Let me run the code. Yeah, here we got the output. Under the instructor ID 102, the project count is 1. Under the instructor ID 101, the project count is 3. Let us move on to the next query. Write an SQL query to list all students enrolled in a specific course along with the name of the instructor teaching that course. For this, let us consider the course-based database systems. Now we need the list of all students who are enrolled in the database system course, along with the name of their teacher which they have chosen. So here's the code for that. Let me explain the logic behind this code. First, we are joining the enrollment table with the student table with the student ID. And with that result, we are joining the result with the course table. And then we are joining with class. And then we are joining with the instructor table. Let me run this query. Yeah, for the course database system, there are two students. Student ID 1 have chosen the instructor named Dr. Smith, and the student ID 2 have chosen the instructor named Dr. Smith. Let us move on to the next query. Write an SQL query to list all projects along with the corresponding student and supervising instructor details. So here we will be joining the student table and the instructor table with the project table. Yeah. The project and student table are joined using the student ID, and that result is joined with the instructor table with the help of instructor ID. Let me run this code. Here we have the list of all students along with the corresponding supervising instructor details. So for the student 1 named Alice Brown, here the faculty is Dr. Smith. And for student 2 named Bob Smith, the faculty name is again the Dr. Smith. For student 3 named Charles Davis, the name of the faculty is Dr. Johnson. And for the student ID 5, the name of the faculty is Bob Smith. With this, we completed the 8th query. Let us move on to the next query. Write an SQL query to calculate the age of each student based on their date of birth. For this, we'll be using the date function. And here's the query for that. Let me explain the logic behind this query. The variable sysdate stores the current date. With this, we are extracting the year and we are subtracting it from the year of the date of birth of the corresponding students. That's the logic behind this query. Let me run this query. And here we have the output. For the student ID 1, the age is 24, and for the student ID 2, the age is 25. For the third student, the age is 23, and for the last student, the age is 20. Let us move on to the next query. Write an SQL query to list all students who are born in the last 24 years. Display their student ID, full name, and date of birth. Here we have the code for birth. Basically, for each student who are available in the student table, we are extracting the month from their date of birth. And we are subtracting minus 288, which is nothing but the month of the given of the current date. Let me run this query. Here we got the output. So for these two students, the date of birth is within the last 24 years. So with this, we complete the demonstration of the query execution. Thank you.